students, in this video we are going to learn about intersection of a line and a plane. Here what they mean is they mean to find out the coordinates of the point where the line meets the plane. Hence we need coordinate of x, y, z. Hence if the plane equation and line equations are given in vector form, means it has to be converted in Cartesian form. Using the Cartesian form we can very easily find out the point of intersection of line, that is coordinates of the point of intersection of the line and plane. Hence we must make sure that the line equation and the plane equations are in Cartesian form before proceeding further. So let the equation of a line be x minus x1 by L is equal to m minus y minus y1 divided by m is equal to z minus z1 by n. Actually here L-M-N denotes direction ratio because and that of a plane equation is given ax plus by plus cz plus d equal to 0. Here coefficients of x, y, z are direction ratio of the plane. Again, if we give the direction ratio of the line as a, b, c, means both these lines drs of normal and plane equations dr of normal will be same, but they may be different. That's why they have given LMN. Even though they mention LMN, they denotes direction ratio of the direction ratio of this line. Direction ratio of the line is different from direction ratio of the plane. That's why they used different notations, but in general we see x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. Instead of writing a, b, c, they wrote LMN to differentiate that drs of normal of this plane is different from dr of the normal of this line. Now we will get into the problem. Now the coordinates of any point of the line can be given by, actually it represents the line equation. Line is formed by combination of infinitely many points, right? So all those points can have the general coordinates. The coordinates of any point on the line can be given by, let us assume that x minus x1 by L is equal to y minus y1 by m is equal to z minus z1 by n is equal to r. It is a constant because it is in the fraction form. Fraction definitely will produce a value. That value we assume it as r. It is a constant, right? Our aim is to find out coordinates of any point using the parameter. If we get the value of r, we can find out the x value. You just look at this, x minus x1 by L is equal to r. L can be transferred here and then x1 can be transferred to opposite side. So x is equal to x1 plus LR, right? So we can find out the general coordinate of this x coordinate. Similarly, y minus y1 by m is equal to r means m can be transferred that y1 can be transferred here. So y is equal to y1 plus mr. Similarly, we can find out z is equal to z1 plus nr. So if we know the r value, this value, we can find out the coordinates of x, y, z. Particular point depends on the value of r. If our value of r is 1 means it will give different x coordinate, y coordinate, z coordinate. If r value is equal to 2 means it will give another point on this same line. If r value is equal to 3 means we will get different x, y, z coordinate value that will give the different point on the same straight line. Hence based on the value of r, that is parameter value of r, we will get different x value, y value, z value that will represent a point on the same line. Hence we can say that this is the general coordinate, general x coordinate, general y coordinate, general z coordinate which lie on this straight line. So if it lies on the plane, now we are expected to find the point of intersection of the line and plane. We calculate a general point. If the line meets the plane means there will be the meeting point will lie on the line as well as the plane. If this is the general point, it represents the coordinates of all general point on the line means if it falls on the plane means definitely it must satisfy the line equation. So in place of x, y, z we can substitute this coordinate value x1 plus lr, y1 plus mr plus z1 plus nr. When we substitute it, it will satisfy. We can find out the value of r. You just check it. In place of x we have substituted x coordinate value, and in place of y we have substituted y coordinate value, z coordinate value, and we simplified it. We finally got the value of r, that is parameter. So for this value we can find out the point of intersection. For this particular r value we will get one x value, one z, y value, z value, that will satisfy the plane equation, as well as that point will lie on the plane. So it is the common point between the plane and the straight line. Hence this is the intersecting point of the line and plane. So substituting this value of r in 1 we get the point of intersection. You just look at it. 1 means the r value is substituted here. So this point, for this particular r value we get a point which satisfies plane equation as well as line equation. Hence it is the intersecting point of line and plane. I hope you understand this explanation. This concept is very important concept. Frequently we get questions in CBSE board exam based on this concept. So students, please understand this. The procedure that we follow to prove it will be applied in the problem to get the point of intersection of a line and the plane. Now we move on to a problem. Find the coordinates of the point where the line through the points A and B crosses the xy plane. First, what we need to do is we need to write the line equation in Cartesian form, and then we need to find out the Cartesian form of xy plane. After that only we can proceed. So our first aim is to find the equation of line, Cartesian equation of the line. If 2 points are given through which the line passes, means the equation of the straight line, Cartesian equation of the line passing through 2 given point, means it is given by x minus x1 divided by x2 minus x1, which is equal to y minus y1 divided by y2 minus y1, which is equal to z minus z1 divided by z2 minus z1. We are just applying those values here and we are getting this expression. Hence equation of the line passing through the points A and B is given by x minus 3 divided by 2, y minus 4 divided by minus 3, which is equal to z minus 1 divided by 5. After finding the line equation which passes through A and B, we need to find the coordinates of the general point. For that we will assume that equation value is equal to something r, from which we can calculate x coordinate value. This 2 can be multiplied with this r, 2r plus 3. Similarly, y can be written as minus 3r plus 4, z can be written as 5r plus 1. This is the coordinates of the general point. Any point on the line can be represented like this. Based on different values of r, we will get different values of x, y, z that will lie on the plane. In case this point lies on the plane, means it must satisfy the line equation. Here you just read it. So 2r plus 3 minus 3r plus 4, 5r plus 1 are coordinates of any point on the line passing through A and B. If this line lies on xy plane, means xy plane is generally denoted as z equal to 0, then z coordinate value will be equal to 0. Here z coordinate value is 5r plus 1. So 5r plus 1 equal to 0, from which we can calculate r value is equal to minus 1 by 5. So for this value of r, the equation for this value of r, 1 minus 1 divided by 5, these coordinates will lie on the plane as well as it satisfies the plane line equation. Hence this is the point of intersection. For this r value, when we calculate some coordinates, when we substitute r value in this place, we are getting x coordinate, y coordinate, z coordinates here. This coordinate values will satisfy the line equation as well as plane equation. Hence this is the common point between line and plane. Hence this is the point of intersection. I hope you understand this. This is a lengthy concept, but if you understand the concept clearly and thoroughly, it will be easy for you to solve it. And I once again say this is a very important problem for board exam point of view. With this I am completing the video. Thank you students. Thanks for your cooperation.